Welcome pre-cal students to class today. Guys, I'm going to bypass, skip the usual announcements. You know you have a test on Monday. You know to have your integrity sheets done. And those that need to make an appointment to see me, please feel free to do that over the weekend. Here's the review sheet in front of you right here. There's a total of 30 problems. If I sound rushed, I'm not. Please don't think that I am. I'm just focused. I know what we have to get accomplished. And there's a very good chance I'm going to do 15 out of these 30 problems and then pause the video, take a little break, and do 15 more. So if I do not finish all of these problems, then you know to look for a part 2 on this review sheet, okay? So with that in mind, there are 30 altogether, plus study your word problems, study them. It's very, very important. Okay, go ahead and turn to page 632, and we're starting off with 7, 10, 14, 18, etc., all the way across here, okay? I was looking for my calculator. I don't see it. Hopefully we don't need that yet. So, all right, here we go. Page 632. Let's take a look at number 7. The directions for 7 and... I think I went too far. Nope, I did not. The directions for 7 say to graph the complex number and find the absolute value. Now in the directions, they call this a complex number. So if you know it's a complex number, then you know that it's missing an imaginary number. Remember, a complex number has to have a real number and an imaginary number. So because there's no imaginary number with the 3, then we're going to put 3 plus 0i. Now how did I know to do that? Because the directions said we have a complex number. So as soon as you knew you had a complex number, you know that you have to have a real number and you have to have an imaginary number together. Okay? Now, we're going to graph this on the complex system. So here we go. This is my real number axis, and this is my imaginary number axis. So 3 plus 0i is really, students, the same thing as 3 comma 0. You go over 3 and you go up and down 0. So this complex number graphed would be this point right here. It's that easy. Now, the directions also say to find the absolute value of this complex number. Well, remember how to do that? We take the square root and we take this number here and we square it. And we take this number here that's with the I and we square it. And we add those two numbers together and take the square root. So 3 times 3 is 9, 0 times 0 is 0, 9 plus 0 is 9, and the square root of 9 is 3. So there's the absolute value. So we would write it like this: the absolute value of 3 plus 0i is 3. Okay? All right, let's continue on. Number 10, the directions say express the indicated number in standard notation and trig notation. Standard notation and trig notation. Okay, first of all, let's write it in standard notation. This is an ordered pair that is at negative 1, 0. Negative 1, 0. So we would write negative 1 plus 0i. That's standard notation. Now, if you did not want to write the 0i, you did not have to. You could just write negative 1. That's totally fine. Okay? Now they want us to write this ordered pair right here in trig notation. So remember, you start here and you rotate all the way to the hypotenuse. Now there's really no hypotenuse because the actual point's lying on the x-axis. But we know that we've rotated 180 degrees and we know that we're out negative 1. Now we don't worry about negative, okay, listen to me, we don't worry about negative when we're dealing with the distance from here to here in the trig form, because that's just the length of the hypotenuse or the length of this line right here. Okay, so we're not going to put a negative 1, we're going to put a 1, and then we're going to put, actually I need a little more room, so let me clear this off. I'm going to put a 1 and then parentheses, and then I put cosine 180 plus I sine 180. All right, and that is that number written in trig form. Now let me say something else to you. what if this ordered pair had not fallen right on an axis? I want to address that very quickly, okay? What if it would have been this point right here? How do you write that point in trig form? Well, you draw a length right to the origin, you rotate around to here like that. Actually, don't do that first, I apologize. You draw this line here. Let me back up. If I gave you this point right here and I said write this ordered pair in trig notation, you would draw a line to the origin, then you would draw a right triangle onto the x-axis like this, a right triangle, and then you would know the length of the triangle going this way is 4 and the length of the triangle going down is 2, and you would find the hypotenuse by using Pythagorean's theorem, and what you would get is the square root of 20, square root of 20. Of course that can be broken down, but I'm just trying to show you what to do. You would find the square root of 20. And so, or excuse me, you would find the length of the hypotenuse, which is the square root of 20. So you would have square root of 20, and then you would have, you start here and you go all the way to the hypotenuse. Now we've got to find this angle inside the triangle, so I would say tangent of x, we'll call it x right here, tangent of x, that angle, equals opposite over hypotenuse. Opposite over hypotenuse. So tangent of x equals 1/2. Now, anyways, I mean, I don't have a calculator in front of me, I don't have the table in front of me, but whatever angle you would get, let's just make something, say it's 30 degrees, then it would be 180 plus 30 more, so you would write cosine of 210 plus I sine 210. Okay, so that's how you do that. All right, moving on to number 14. Number 14 says find trig notation. Find trig notation. So here we go. We understand that we're rotating around. I don't care if my drawing is to scale. I just know that I'm going negative x and then positive y. So, or negative real number, positive imaginary number. So I know I'm going left and then up because this is a negative number and this is a positive number. So left and then up. Put my point here. Draw my line, draw my right triangle, and I know the length going over right here is 10 square root of 3, and I know the length going up is 10. Now the first thing we do is we find the hypotenuse, so we square the 10 and we square the 10 square root of 3, and we take the square root of that. Now 10 times 10 is 100. Now when you square this, be careful. You square the 10, which is 100, and you square the square root of 3, which is 3. Let me go over that again. You square the 10, that gives you 100. You square the square root of 3, which is 3, and multiply those two together, and you get 300. Okay? Add those two together, and you get 400, and the square root of 400 is 20. So now I know the hypotenuse is 20. Now, the next thing we're going to do is we're going to find this angle inside the triangle right here. So we're going to say the tangent of x equals opposite over adjacent. Opposite over adjacent. Our 10s would cancel, so we're left with the tangent of x equals 1 over square root of 3. And we all know by now 1 over square root of 3 is the same thing as the square root of 3 over 3. And I have a feeling we're going to need our table today, so I'm going to very quickly take care of that right now in front of you. And we're going to use this table from here on out. Alright, so tangent of what angle gives me square root of 3 over 3. Tangent of 30 gives me square root of 3 over 3. So I know this angle right here inside the triangle is going to be 30 degrees, so I put a 30 right here. Then I rotate from here to here. So the angle is 150. So the hypotenuse is 20, so I put a 20. Then I put my parentheses, and then it would be cosine of 150 degrees plus I sine 150 degrees. All right, let's move on to the next problem, number 18. We're going to write the trig form of 4. So the first thing we do is we get a picture of it, and that's 4 plus 0i. So I'm going over positive 4, and I'm not going up any or down, so I'm right here. So 1, 2, 3, 4. All right, now let's think this through for a second, okay? There's no right triangle we can draw, and there's really no angle we can find or no hypotenuse, so here's the deal. We don't go anywhere. I mean, we're not going to go like this and put 360. I guess we could. We're not going to do that. We're going to say that we're not moving at all, so the degree we're dealing with is 0 degrees, and there's really no hypotenuse, but we know the length from here to here is 4, so whenever it lies on an axis, that's how you do that. So you would say the hypotenuse is 4, and then you would say cosine of 0 plus I sine 0. Now if you put 360, I would have no problem with that, because the cosine of 0 is the exact same thing as the cosine of 360. So I would accept either one of those answers. All right, let me quickly grab a drink of water here, and let's move on to the next problem. Okay, we're going to write this in trig notation, okay? Now notice it's a negative and a negative, so that's going to put me in this quadrant here. I don't mind if I draw it to scale. I know I'm going negative and negative, so I'm going to put a point way down here so I got a nice big triangle I can draw. Draw that line, draw my right triangle, and here we go. The length here is going to be 9 halves, and the length going down is going to be 9 square root of 3 over 2. Now the first thing we do is we find the hypotenuse. So remember, we take 9 halves and we square it, plus we take 9 square root of 3 and we square it, and we take the square root of that. Now squaring 9 over 2 is easy. 9 times 9 is 81, and 2 times 2 is 4. That's pretty easy. But this one over here is going to be a little more complex. Let's work it out down here. If I square the denominator, 2 times 2 is 4. That's easy. If I square the top, not the numerator, 9 times 9 is 81. And then if I square the square root of 3, I just get 3. So 81 times 3. So really I end up with 243 over 4. All right? So 243 over 4. Now these two fractions have a common denominator, so add them together. When you add two fractions together with a common denominator, you leave the denominator alone. If you want to use a calculator to add those, that's totally fine. I have no problem with that. Let's see, we would have a 4 and then a 2, 324. Now the square root of 324 over 4, we can split that up. The square root of the top is 18, and the square root of 4 is 2. So the square root of 324 over 4 is 18 over 2, which is 9. A lot of work, but that's the hypotenuse, 9. Okay? Now, with that in mind, now we've got to find the angle inside the triangle. We'll call that x, and we're going to say the tangent of x equals opposite over, and you know what, hold on a second, can we use common sense here, students? Usually I use tangent, but in this case here, this is going to be a tough problem to use. Why make life hard? Let's use this side here and this side here. I mean, 9 half and 9 are a lot easier to use. So the name of this side here is adjacent. The name of this side is hypotenuse. So let's say this, the cosine of x equals adjacent over hypotenuse. That's a lot easier, okay? And so if we simplify that correctly, 9 over 2 divided by 9, we will get 1/2. And now what angle, when you take the cosine of it, gives you 1/2? Well, let's see. The cosine, here it is, the cosine of 60 is 1/2. So I know this angle right here is 60, so I know the angle right here is 60, so I'm going to rotate from here all the way to here, and I get 240. So trig form is the hypotenuse, which is 9, and then cosine of 240 degrees plus I sine 240 degrees, and that would be trig form. Okay, all right, moving on to the next number, 24, and it says to write in standard notation. Now students, I do want you to use exact numbers when you can. And the first thing you might think of is, well, Mr. Earhart, 120 is not on our special table. You're right, it's not. Our special table has 30, 45, and 60, but hold on. There's a reference angle for 120 degrees. You've got to learn to check for that, students. Look, if I rotate 120 degrees and stop, the reference angle for 120 degrees is this leftover angle right here, and that's going to be what? 60 degrees. So instead of taking the cosine of 120, you're allowed to take the cosine and the sine of 60 degrees. You're allowed to do that as long as you remember the sine sequence. Positive, negative, negative. In other words, you can take the cosine of 60. I'm going to go ahead and write this down. You're welcome to take the cosine of 60, but you better put a negative sign out front, because whatever you get is going to be negative. And you're more than welcome to take the sine of 60 as long as you remember to put a positive sign out front. And that positive sign is already there because sine is positive. And now we can do this very quickly. Here's our table. What is the cosine of 60? Well, the cosine of 60 is 1/2. So I have 6 parentheses negative 1/2. What is the sine of 60? Well, the sine of 60 is square root of 3 over 2. So square root of 3 over 2. Don't forget your I. Okay? Now, if you put the 6 over 1 and multiply it through, 6 over 1 times 1 over 2 would be negative 3. 6 over 1 times square root of 3 over 2 would be 3 square root of 3, because your 2 would cancel into your 6 3 times. All right? So we're left with this right here for the trig form. All right? Not too bad. Let's take a look at number 8. We're going to also write this in trig form, or excuse me, in standard form. And I hope I said that for the last problem. This is standard form. You have written this trig form, you have written it in standard form. Okay, we're going to write this in standard form. Now, if you look at your table, we don't have 0 degrees on our special table. So you can use a calculator for these. Well, 3 parentheses, cosine of 0 is going to be 1, plus the sine of 0, I believe, is going to be 0. Yes, that's correct. So 0i. Take your 3 and multiply it through. 3 times 1 is 3. 3 times 0 is 0i. You are more than welcome to write your answer like this. You're also welcome to just write your answer like this. Okay? Moving on now to the next problem, number 28. The directions for 28 say to write this in standard form. Now I'm going to go ahead and convert this to degrees. Pi over 3 is 60 degrees, and pi over 3 is 60 degrees. This should be really, really easy, students. I mean, look, all that we're doing here is we're just finding the cosine of 60 and the sine of 60. So here's cosine, here's 60, 1/2. So I have 5 parentheses, the cosine of 60 is 1/2, plus the sine of 60, well, sine of 60 square root of 3 over 2. And now simply take your 5 and multiply it through. Put the 5 over 1. 5 over 1 times 1 over 2 would be 5/2. 5 over 1 times square root of 3 over 2 would be 5 square root of 3 over 1 times 2, which is 2. Don't forget your I. And that is the answer in standard form. Okay? All right, we're going to multiply these two together, and it says to multiply them and leave your answer in trig form. So we're just going to multiply and leave it in trig form. Here we go. So we multiply the hypotenuses. 5 times 2 is 10. And we add the angles. That's what you do when you're multiplying two numbers. Well, this is 60 and this is 45 degrees. Pi over 3 is 60, pi over 4 is 45. So 60 plus 45 would be 105 degrees. and of course you're adding the exact same angles here and here, so it's I sine 105 degrees. Now, to be honest with you, in a normal math classroom, if the original problem was written in radians, then they're going to want your final answer to be in radians. I'm not super strict on that, but it is something you need to be aware of. So if you were to convert 105 degrees over to radians, you would get 7 pi over 12 plus I sine 7 pi over 12. All right, let's move on to number 11. Let me grab a quick drink of water here. And here we go. The directions for 36 say divide these two numbers and leave your answer in trig form. Now the first thing we do is we divide these two numbers here. So we take 1/2 and we divide it by 3/8. Now you can use your calculator if you want to, or however you want to do it, but I do want you to give an exact answer. I don't want it in decimal form. So 1/2 divided by 3/8 is 4/3. Okay, use your calculator if you're weak with your decimals. And now I like to use degrees. To me it's a lot easier. So this would be 120 degrees, and this would be 120 degrees. This would be 30 degrees, and this would be 30 degrees. Now when you're dividing two complex numbers that are written in trig form, you divide these numbers. So we took 1/2 divided by 3/8, flip that fraction, multiplied, we got 4/3, and then you subtract your angles. You take your top angle minus your bottom angle. So 120 minus 30 is 90 degrees, and of course it's the same angles over here, 120 minus 30 degrees. If the original problem was written in radians, you really should write your final answer in radians. So 90 degrees would be cosine of pi over 2 plus I sine pi over 2. All right, so not too bad. Okay, not too bad. Let's continue on. Let's take a look now at the next one, which is number 38. Number 38 says convert to trig notation, then multiply or divide. We're multiplying here, so I'm going to convert these to trig notation very quickly. So here we go. Let's start off with this number right here. Notice I have a positive and a positive, so I'm over and I'm up, so I'll put my triangle right here. I'm over 1, I'm up square root of 3. If you use Pythagorean's theorem, trust me, you'll get a 2 here. I'm not going to break that down for you. I'll just simply write this. You'll have the square root of 1 squared plus square root of 3 squared. Work that out and you'll get a 2. Now we're going to find this angle here. I'm not going to use the square root. I'm going to use a 1 and a 2 to find this angle, and that's adjacent and hypotenuse. So I'm going to say cosine of x equals adjacent over hypotenuse. If I look at my table, I can see that the cosine of 60 is 1/2, and so I know the angle here is 60, and so I rotate up to 60. So this number here in trig form is hypotenuse of 2 and then an angle of 60. So cosine of 60 plus I sine 60. All right, now we've got to take the other standard form complex number and write it in trig form. Notice it's a positive 1 and a positive 1, so I know I'm going to be over and up. And I like to draw really big triangles to give me a lot of room. I'm over 1, I'm up 1. If I find the hypotenuse, I'm going to get the square root of 2, and that would be because the square root of 1 squared plus 1 squared would give me this. Now I'm going to find this angle here. I'm going to use these two numbers because they're a lot easier than a radical. So I'm going to use opposite and adjacent. So I'm going to say the tangent of x equals opposite over adjacent, 1 over 1, which is just 1. Let's take a look at our table very quickly. It looks like the tangent of 45 is 1. The tangent of 45 is 1, so I know the degree inside the triangle is 45 degrees. I'm going to rotate up to here. So my trig form is, put a dot here, the hypotenuse is the square root of 2, and then I would have cosine of 45 degrees plus I sine of 45 degrees. And now I'm ready to go ahead and multiply these two numbers together, these two complex numbers. So hypotenuse times hypotenuse, 2 times the square root of 2 is 2 square root of 2, and then you add your angles. Cosine of 60 plus 45 is 105 degrees, plus I sine, and then 60 plus 45 is 105 degrees. And that would be the answer. Okay, let's move on now to number 44. Same thing. They want us to write each one of these numbers in trig form and then divide. So here we go. Notice the top number, this complex number right here, is positive and then negative. So that means I'm going to go over positive, down negative, draw a really nice big triangle to give myself plenty of room to work. Here's my right triangle. I go positive 3 and then down 3 square root of 3. If you use Pythagorean's theorem, you're going to square the 3 and you're going to square the 3 square root of 3, which would give you 9 plus 9, 3, 27. So you get the square root of 36, which is 6. So the hypotenuse will be 6. I am going fast on these now, but students, we should know how to square this, okay? When you square 3, you get a 9, and when you square a square root of 3, you get a 3, and 9 times 3 is 27, okay? And then go from there and finish it. Now, let's find this angle on the inside. You're welcome to use this side. I'm not going to. I don't like the radicals. I'm going to use this side and this side. That's adjacent and hypotenuse. So I'm going to say the cosine of x equals adjacent over hypotenuse, which is 1/2. So what angle, when I take the cosine of it, gives me 1/2? Well, let's see. The cosine of 60 is 1/2. So I can see that it's 60 degrees inside the triangle here. So I'm going to start here and rotate all the way around. My angle is going to be 300 degrees. So this top angle right here, the hypotenuse is 6, and then I would have the cosine of 300 degrees plus I sine of 300 degrees. Alright, now let's take this denominator, this bottom complex number, and let's see if we can't write it in standard form. Notice once again the first number is positive, the second number is negative, so that's going to put me over positive, down negative. So right here, let's draw a really big triangle so we got plenty of room to work. We're going to go over square root of 3 and down. There's no number in front of the I here, so it's understood to be a 1. We're going to go down 1. Now using Pythagorean's theorem, we should get a 2 right here, okay? If you square the square root of 3 and you square 1, you get 3 plus 1 is 4, square root of 4 is 2. Now, this angle on the inside here, we're going to find that angle. We're going to use these two sides right here. And this is the opposite side, and this is the hypotenuse. Now, why did I choose these two sides? Because I don't want to use a radical. Why should I use a radical when I don't have to? So 1 and 2, opposite over hypotenuse. Opposite over hypotenuse is sine. So I'm going to say sine of x equals opposite over hypotenuse. And what angle, when I take the sine of it, gives me 1/2. Well, let's see, here it is. Sine of 30 is 1/2. Sine of 30 is 1/2. So I know my angle inside the triangle is going to be 30. So I know I'm going to rotate around and get 330 degrees. So I'm going to have 2 cosine 330 degrees plus I sine 330 degrees. There. That's a lot of work, but what we've done is we have now basically to it. We've taken these two numbers, these two complex numbers that were written in standard form, and we have rewritten them in trig form. So what I'm going to do now is I'm going to get rid of this. I don't need it. I've rewritten it into this form right here. So I'm going to put it down here and get rid of it. And now, how do you divide these two numbers? Remember, you take the top number, the top hypotenuse divided by the bottom. That would give you 3. And then you subtract the angle. So 300 minus 330 would be cosine negative 30 degrees. And I have no problem. What I don't want are angles that are over 360 degrees. If you're negative, that's fine. Just don't go over negative 360. But I don't mind you having negative angles, so you're welcome to put negative 30. And you know what? If you don't like negative 30 is this right here, right? That's negative 30. If you want to put a positive 330 instead, that's totally fine, because that's the exact same thing as negative 30. But either way, 300 minus 330 is negative 30, 300 minus 330 is negative 30, and that answer is totally acceptable, okay? All right, let's take a look now at the next problem. Number 50, and the directions for 50 say, raise the number to the given power and write in standard notation. So we're going to raise this to the 9th power. Now here's how you do it. Remember, you take the number on the outside, in this case it's a 2, and you raise it to the power of whatever's on the outside here. In this case it's a 9. And then these numbers on the inside you multiply. You don't raise the 10 to the 9th power, you multiply the angle times the number that's right here, this number. And so 10 times 9 is 90, so we have cosine of 90 degrees plus I sine of 90 degrees. Now they want us to write this in standard form. The sine and cosine of 90, if you look at your table, we don't have that anywhere on our table at all, and so we're going to use our calculators. Now the cosine of 90 is 0, and also 2 to the 9th power is going to be 512. So we have 512, and then cosine of 90 is 0, plus, and then the sine of 90 is going to be 1, so 1I. Now multiply your 512 through. 512 times 0 is 0. 512 times 1 is 512I. Okay? Very good. Not too bad. And now you have written that in standard form. Let's take a look at number 62. The directions for 62 state as follows. Find the cubed root. Now the first thing we're going to do is we're going to write it in trig form. So very quickly, notice I have, in fact, didn't we write that one in trig form just a little bit ago? I thought we did. Let's see if we did. 1 minus, it might have been the one, what number was this here? Before number 50. Give me just a second here. Before number 50 was 44. And no, we did not. So I guess I wasted a little time there. I apologize. I thought we had changed this number earlier over to trig form, but we have not. So notice we have a positive number and a negative number. So we go over positive, down negative. I like to draw a nice big triangle to give me plenty of room to work. I go over 1, down square root of 3. The hypotenuse would be 2, because you square the 1 and you square the square root of 3, and then you get 4, and you take the square root of 4, which is 2. Now we're going to find this angle right here. We're going to use 1 and 2. So we're going to say the cosine of x equals adjacent over hypotenuse. And of course, the angle that when you take the cosine of it gives you 1/2, is cosine of 60 is 1/2. So I know the angle inside the triangle here is going to be 60. So I'm going to rotate around 300 degrees. So what I get is a hypotenuse of 2 and then cosine of 300 degrees plus I sine of 300 degrees. All right, so there we go. And now we're not done. All that we did was write the number from standard form to trig form. Now they want us to take or to find the 3 cubed roots. Find the 3 cubed roots. Now here's how you do it. I'm going to put right up here what we're doing. We're finding the cubed root. So whatever root you're finding, you take the root of the number here. So you take the cubed root of 2. So again, whatever root you're finding, the square root, cube root, fourth root, fifth root, sixth root, doesn't matter. Whatever root you're finding, you take that root of that number right here. If this was a fourth root, then you would take the fourth root of 2. If this was a fifth root, then you would take the fifth root of 2. This is a cubed root, so I take the cube root of 2. Now next, whatever this number is right here, cubed root, fourth root, fifth root, sixth root, whatever this number is right here, you take the angles and you divide by that number. So we're going to take 300 and divide by 3. If it would have been a fourth root, then we would divide by 4. If it was a fifth root, we would divide by 5. So I take 300, I divide it by 3, and I get 100 degrees plus I sine, and then 300 divided by 3 is 100 degrees. So there, you found the first cubed root. However, if it's a cubed root, there'll be 3 answers. If it was a fourth root, there'll be 4 answers. If it's a fifth root, there'll be 5 answers, etc. So what I've taught you to do is you always take 360 no matter what, period, no questions asked. That never changes. And you divide it by whatever this number here is. In this case, it's a cubed root, so divide by 3. When you do that, you get 120. And that's the angle you add over and over and over. So your next answer would be square root of 3, or cubed root of 2, excuse me, and then cosine of 220, because we added 120 to the 100 degrees I already had. Now that's your second answer. We need one more answer. So now we're going to add 120 degrees again. So we get cubed root of 2, and then cosine of 220 plus 120 is 340. So 340 degrees plus I sine 340 degrees. And those are the 3 cubed roots of this number right here. All right, let me grab a quick drink of water. And let's take a look at our next problem. And I think I'll do this one here and then take a break and do the other 15 after I've taken a break, okay? Find and graph the 6 roots of, I know this is really blurry, but I never feel bad about that because you can look in your book if you need to. And it says find and graph the 6 roots of 1. Now we do understand it's a complex number, so I really have 1 plus 0i. Now I'm going to write that in standard form very quickly. You're going to see how easy it is. It's a positive 1 and a positive 0. So I go over 1 right here, and I don't go up and I don't go down. So really, students, this is simple, okay? That means I have a length of how far here, a 1, and I have what for my degrees? 0. So to write this in trig form, I have a hypotenuse of 1, and my trig form would be 1 cosine 0 degrees plus I sine of 0 degrees. Now look, students, I haven't done anything yet, except take this number right here and write it in trig form. That's all that I've done. I have not even started to solve the problem. So I have this number right here written in trig form. Now I'm going to find the 6 roots, or the 6 sixth roots. So I'm going to put that right here so I don't forget what I'm doing. And now I've taught you what to do. This is not your first answer. This is just this number here written in trig form. So your first answer will be, well, I've taught you what to do. You take the 6th root, because that's what you're dealing with, is the 6th root. You take this root of the outside number. So I have the 6th root of 1, and then I taught you from there you take the angle and divide it by whatever number you have here. So 0 divided by 6 would be 0, and I sine divided by 6, or I sine 0, 0 divided by 6 would be 0. Now there's my first answer right there, and I can simplify it a little bit, so I'm going to go ahead and simplify it right now. And we all know that the 6th root of 1 is just 1. So I'm going to go ahead and put a 1 on the outside. And you say, well, Mr. Earhart, it ended up matching this number right here. That was a coincidence. That won't always happen, okay? But in this case, it did. Now, we need 5 more answers for a total of 6. So remember, how do we know what to put? Well, you always take 360. That will never change. And you divide it by whatever your index is. So divide by 6. And you get 60. So we're just going to add 60 over and over and over until we have 6 answers. So it's just, I'm going to write really sloppy and just get it over with. 1, 0 plus 60 is 60. Plus I sine 60. Now we're going to add 60 again. Notice how the hypotenuse doesn't change. 60 plus 60 is 120, plus I sine 120. Now we're going to add 60 again. 120 plus 60 is 180 plus I sine of 180. Now we're going to add 60 again. 180 plus 60 is 240 degrees plus I sine of 240 degrees. And now we're going to add 60 again for our final answer, and we have 1 cosine of 300 degrees plus I sine of 300. How do I know to stop there? We'll count your answers. We've got 1, 2, 3, 4, 5, 6. And if I've asked you to find the sixth root, then that means you find 6 answers. So there are the sixth roots of this complex number right here. All right, I'm going to go ahead and take a break there. That's the first 15 problems. We have 15 more to go. And so there will be 2 parts to this review sheet video.